Jai Hind, 11th class maths. Today we are doing arithmetic progression series. Here the first question is, write first 5 terms each of the following sequences whose nth term are an equal to n plus 3. So in this question we write the solution. We write n equal to 1. So it becomes first term a1 and n equal to 1. So n we replace with 1. So first bracket we solve. So 1 plus 3 is 4. 4 into 1 is 4. So first term is 4. Now replace n equal to 2. So we get a2. Second term. So n is here. We replace with 2. So bracket solve. 2 plus 3 in bracket 5. 5 outside there is 2. So bracket means multiply. 5 to the 10. Second term is 10. Next replace n equal to 3. N equal to 3 and we get a3 equal to 3. N is 3, so 3 plus 3 bracket solve. 3 plus 3 is 6. So 6 into 3, that gives us 18. Next we replace with 4. N equal to 4. So 4 plus 3 bracket solve. 4 plus 3 is 7. 7 into 4 is 28. So fourth term is 28. Next n equal to 5. We get a5. Replace n equal to 5. So 5 plus 3, first we solve 8. 8 into 5, 40. So a5 is 40. So first 5 sequences of this series is 4, then 10, then 18, then 28, then 40. This is the answer we get here. Next question number second part. Similarly here we replace n equal to 1. A n equal to n upon n plus 1. So a1 equal to 1 upon 1 plus 1. So 1 upon 1 plus 1 is 2. Now n equal to 2. It gives a2 1 upon 1 plus 2. So this 2 and 1 can interchange. So in denominator n equal to 2. So numerator also become 2. So gives us 2 upon 3. Next n equal to 3. So a3. So n upon n plus 1. 3 upon 3 plus 1. So 3 upon 4. Next n equal to 4. It gives us a4. 4 upon 4 plus 1. That gives us 4 upon 5. Next n equal to 5. It gives us a5. 5 upon 5 plus 1. So it gives us 5 upon 6. So first 5 terms are here we get 1 upon 2, 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6. The next question is, find the indicated term in each of the following sequence whose nth term is given an equal to 4n minus 3, a17, a24. So for a17, what we do? N equal to 17. Put n equal to 17. So a17 equal to 4 into n. It means 4 into 17 minus 3. 17 4 ja 68. 68 minus 3. That gives us 65. Similarly, for a24, put n equal to 24. So a24 equal to 4 into 24 minus 3. 24 4 ja 96. 96 minus 3, it gives us 93. So this is the answer. In second part, an equal to n cube upon 2 power n, we need a7. So for a7, we put n equal to 7. So a7 become 7 cube upon 2 power 7. This is the answer. 7 cube is 7 into 7 into 7, 343. 2 power 7 is 250. 2 power 7 is 128, not 256. This is the answer. Here is next question. Write the first 5 terms of each of the following sequence and obtain the corresponding series. A1 is given 3. It means first term is given 3. And an is formula given 3, an minus 1 plus 2 for all n greater than 1. This is called Fibonacci series because previous term is needed. A1 is previous term and next term is obtained from previous term. So we put n equal to 2. We get a2 equal to 3, a2 minus 1, that means a1 plus 2. a1 value is 3. So we replace here 3 into 3 plus 2. 3 into 3 is 9. 9 plus 2 is 11. So a2 is 11. After getting a2, we put n equal to 3. So n equal to 3. So a3 equal to 3 into a3 minus 1 plus 2. 3 minus 1 is 2. So it gives a2 plus 2. a2 is 11. We replace with 11 a2. So 3 into 11 plus 2, it gives 11 to 11 into 3, 33 plus 2, 35. So next is put n equal to 4. We get a4 equal to 3 into a4 minus 1 plus 2. So 4 minus 1 is 3. So it becomes a3 plus 2. a3 value we replace is 35 plus 2. 35 3 is 105 plus 2, 107. Next we replace n equal to 5. N equal to 5. We get a5 equal to 3 into a5 minus 1 plus 2. So it gives 5 minus 1 is 4. So it becomes a4 plus 2. a4 is 107 plus 2. 107 3 is 321 plus 2. It gives us 323. Next put n equal to 6. It gives a6 equal to 3. a6 minus 1 plus 2. 6 minus 1 is 5. So it become a5. a5 value is 323. So 3 into 323 plus 2. It gives us 969 plus 2 equal to 971. So finally we get the series as this is called Fibonacci series. So a1 is first term. Then we get a2 11. Then we get a3 35. Then we get a4 107. Then we get a5 323. Then a6 971. So in this way we have obtained 5 terms, 1 2 3 4 5. I hope you are understood. In geometric progression, it is called GP series. In GP series, we consider, suppose 2 is first term, multiply by 2, we get 4, multiply by 2, 4 to the 8, multiply by 2, 8 to the 16, multiply by 2, 32. So this type there is multiplying continuously. Or in another example, 2 multiply by 3, 6, multiply by 3, 18, multiply by 3, 54. So here also multiply by 3. And one more example, 1 by 2, multiply by 1 by 2, we get 1 by 4, multiply by 1 by 2 again, we get 1 by 8, multiply by 1 by 2, we get 1 by 16. This type of series is called GP series. Therefore, GP series general formula is, first term we write with A, second term is AR, third term is AR square, fourth term is AR cube. So fourth term, look, fourth term AR cube, R is 1 less than power. So nth term is ARN minus 1. It is important, AN. This is GP series general formula. So here is A is first term and R is second term divide first term, we get R. So R is everywhere we can divide previous term with next term. So this is the R. N is how many terms is there. This is called GP. Suppose we take series 10, 100, 1000, 10,000. So in this series, A here is 10, R here is second term divide first term. Either we can divide 100 by 10, we get 10, or we can divide 1000 by 100, we get 10, or 10,000 by 1000, we get 10. So R is remain constant. So in this way, the A and R, we select A is first term, R is ratio of two terms, consecutive two terms. And general formula for GP series is ARN minus 1. This is the anth term formula. This is general formula for GP. So we write in rectangle. This is formula. So formula always written in rectangle. So this is general term of GP. And according to it, if we want to find the in the above series 22 term, n equal to 22 we put. So A is 10, R is 10, and 22 means 22 minus 1. It gives 10 as power 21. So 10 as power 21, 10 into 10 as power 21, it gives 10 as power 22. This is the 22nd term in this series. So next our formula is sum of GP. Sum of first n terms of GP series. So there is two cases. If R is greater than 1 or if R is less than 1. So for greater than 1, Sn formula sum for nth term is A R power n minus 1. There is minus is between R power n and 1 upon R minus 1. And for R less than, we replace Sn equal to A one minus R power n upon 1 minus R. We taken common from both numerator denominator and divide, cancel out minus sign, then we get this formula. And there is no cases arise from if R equal to 1. If taken R equal to 1, then what happen? The series will become same. Suppose first term is 2, then we get series 2, 2, 2, 2. And here is common ratio, R is 1. And so this type of series, first term, we get in the whole series term. So next important term here is geometric mean. Geometric mean. In geometric mean, suppose in the if ABC are 3 terms, 3 GP terms, and we get B equal to square root A into C in square root, then B is called middle of the geometric series ABC. So this B is called, in this case, it is called geometric mean. B is called geometric mean in this situation. So we can say B is geometric mean of ABC. A and B, A and C. B is geometric mean of A and C. Geometric mean of A and C. Next here question. Find a number between 1 and 8 so that they form a GP series. So we use formula B equal to under root AC. So A and C are first and third term. So under root 1 into 8 we write down. For A we write 1 and C 8. So square root 8 is the answer, and it is written as 2 root 2. 2 root 2 is the between 1 8, so that this series is formed GP series. And but in AP the middle term is sum of half of the sum of first and last term. So next question is find the 20th term and nth term of GP series, and series is 5 by 2, 5 by 4, 5 by 8. So here A is 5 by 2 and R is second term divide first term. So 5 by 4 divide 5 by 2. What we get? 5 by 4. We replace 5 by 2 by multiplying 2 by 5. Now we solve 5 cancel, 2 cancel 4, 1 by 2. So R is 1 by 2. A is 5 by 2. So 20th term formula is An equal to A R power n minus 1. This is formula for 20th term. So we replace n equal to 20 and A equal to 5 by 2. We get A R is 1 by 2 power 20 minus 1. That gives us 19. So 5 by 2 into 1 by 2 and power is 19. So 1 power 19 and 2 power 19. 1 power 19 is same we get. So we write 2 power 19 and into 2 it gives 2 power 20 because 19 plus 1 20. So 5 upon 2 power 20 is the answer. And nth term we obtain by plugging the value of A 5 by 2, R 1 by 2 and power n minus 1. This is the answer for nth term. Or further we can say 5 into 1 by 2 power n, because n minus 1 plus 1 we get 2 power n. So 5 upon 2 power n is the answer. So here is some rules of exponent that we have to learn. So rules of exponents. This is small 8th class problems. So a power m into a power n, this can be written as a power m plus n. Second rule, we can say a power m whole power n. This can be written as a power m into n. Power multiply. Third rule, a power m divide a power n. It means a power m minus n. So divide means subtract the power. Fourth rule, a power 0, its value is 1. Any number whose power is 0, its value is 1. Fifth rule, a power m into b power m. This can be written as ab whole power m. Sixth rule, a power m upon b power m. This can be written as a upon b whole power m. Seventh rule, if a power minus m, this can be written as 1 upon a power plus m, or a upon b whole power minus m. This can be written as b upon a whole power plus m. So these are all important for anywhere in the problem solution of this type of question. So next question is find the 12th term of GP whose 8th term is 192 and common ratio is 2. So in this type of problem, first what is given that we have to write down. So common ratio is represented by R. So this is given 2. So this is given, and second is given, 8th term is 192. So nth term is formula a r power n minus 1. So a8 is given, a8 is given 192 equal to a r is given 2. So n minus 1. 8th term is given, so n is 8. N is 8. So 8 minus 1 we write down. So 192 equal to a 2 power 7. 8 minus 1 is 7. So 2 power 7 is 120. 2 power 7. 128. So a is 192 upon 128. Further simplified, cancel by. We find the factors of 192 so that we can cancel out. Divide by 2, we get 96. Divide by 2, 48. Again divide by 2, 24. Divide by 2, 12. Divide by 2, 6. Divide by 2, 3. So 3. So how many 2? 1, 2, 3, 4, 5, 6. 2 power 6 into 3. In denominator there is 128. It means 2 power 7. So 2 power 6, 2 power 7 cancel out. Only 2 will left. So 3 by 2 is the first term. We get first term a is 3 by 2, 1.5. So find the 12th term of GP. Now we find A12. A12. So A12 is A is 3 by 2. R here is 2. Common ratio is 2 given in question. Power 12 minus 1. So 3 by 2. 2 raised power 11. 2 raised power 11 is 2048. 3 by 2 into 2048. 2 cancel 2048. We get 1024 into 3. We get 3000. And 24 3 is 72. 3072 is the answer. Our next question is, the 5th term, 8th term and 11th term of a GP are P, Q and S respectively. Show that Q square equal to PS. So in this we write the given. 5th term is given P. So 5th term, first we write general formula AN equal to N A R power n minus 1. This is the general formula. And there is given n equal to 5, 5th term. So it is given equal to P equal to A R power 5 minus 1. That means 4. This is given equation 1. Second is given n equal to 8. So it become A8 equal to Q equal to A R power 8 minus 1. That means 7. This is our second equation. Third, n equal to 11. So it gives A11 equal to S. A R 11 minus 1. It gives A R power 10. This is third equation. So we get 3 equation. So this is the given that we obtain. Now we have to prove Q square equal to PS. Now P into S. P into S we obtain which equation? First and third equation. It gives us P into S. So multiply equation 1 and equation 3. So multiplying, it will give P and S on left side. On right side we get A into R power 4 multiply A into R power 10. So A into A, it gives A square, and R power 4 into R power 10, it gives R power 4 plus 10. So R power 14. So taking 2 common, we can say a square r power 14. It can further written as ar7 whole square. Ar7 is, we can say, this is second equation, so it is second equation means q, so there is q square, it become q square. So therefore we can say LHS equal to RHS. LHS equal to RHS, or we can say PS equal to Q square. That has proved. Hence proved. In the next part we will study it again. Okay.